We spoke about POPSUP as one of the example technologies for persistent store. The counterpart technology that you also need when you build your streaming applications is the stream processing software or streaming framework. That's another way to refer to it. And here again, there are many options. We'll take a look at two of them. One is something called as Google Data Flow. Again, continuing with uh, just an introduction to the Google Cloud Platform as an example technology. There are similar technologies with AWS, with Microsoft, with some of the others as well. And in next week's lectures, we will actually take a look at specifically the open source Spark streaming. So Google Data Flow is itself a combination of few different things. Let's talk about this, and for this, I'm grateful to this specific individual who's actually put together this really nice way to understand what data flow is about. See, data flow is actually a PaaS service. In fact, it's an example of a serverless PaaS service, which allows you to spin up your own, data processing pipelines, be it batch or real time. So, in some ways, this is a lot like the advantage of having Spark, right? So, we spoke about how Spark actually has seamless interoperability between batch and real time. The code looks almost the same, except that there are a couple of connectors that you might need to change just for real time. Likewise, data flow is similar, but the better the thing about data flow is that it also encapsulates the hardware, right, that's required for the processing to execute, and it does not require you to specify anything about the configuration of the hardware that's special, right? So in that sense, it's truly serverless. It spins up its own hardware, etc., etc. Great. So how does it work? First and foremost, Google Data Flow uses a common description language that's called as Apache Beam. And Apache Beam is actually open source. In fact, in many ways, you can think about Apache Beam as being an even more generalized version of Spark, as well as maybe a couple of other options of data processing that you'll typically see, like Flink and so on. So in that sense, the open source Apache Beam is more general purpose, right? And there is actually ability for you to take an Apache Beam code and run it within Spark as well. So we'll see that example in a minute. So you create your data processing pipeline using the Apache Beam SDK, and then data flow becomes the place where you deploy and execute. So notice that the code is actually different from the execution environment. Data flow is the execution environment, and it's a serverless infrastructure, so it allows you to monitor, it allows you to automatically manage scaling and things like that. But the code itself, the logic itself is written using Beam in a way that's open source. All right, so data flow will produce outputs, obviously, and the outputs that it produces is compatible to any of the standard data processing options that you have, which is, emit back to a message store like PubSub, or write it out to like a database, etc., etc. So what really happens behind the scenes? First and foremost, obviously, any data processing pipeline needs an input. That input comes from some kind of a data source. In the case of batch processing, it comes from files, but in the case of real-time or streaming, it comes from a service like PubSub or Kafka. Then the transformations themselves happen. When the transformations happen, it happens on a unit of data, which is parallelly distributed across multiple different servers within, and that unit of data is called P collection. I'll expand on this in the next slide. Once the transformations are done, the transformations themselves are multi-step, again following the hot potato principle, whereby each operation that happens creates a new P collection, and then the new P collection becomes checkpointed, and then it becomes the input to the next operation, and so on. So then, once all those transformations are done, when you finally are ready to write an action, the Spark equivalent of action is here, like data sync. A data sync itself can be like a file, could be one of the databases, etc. Behind the scenes, data flow operates in a manner that's similar to most distributed systems, which is, there's a worker process. The worker process has multiple different instances. Each of it corresponds to like a virtual machine, and then that ability to have those virtual machines scale up and down is completely, possible, right? You can, if you're not happy with the default machines that I've chosen, you can ask it to choose like a higher scale machine, and Dataflow seamlessly manages that without you having to do anything else. In terms of the backend architecture, the server is where the compute happens is separate from where the storage happens. The storage is like not just referring to the sources, but also the P collections, right? Because P collections are checkpointed in the storage system. So those two are completely separate. So therefore, that allows you to scale each of those independently, and then Dataflow can automatically scale up and add more machines as the case may be, based on the performance, based on the workload. Okay, so how do you use a Dataflow system, like Dataflow job? Like with all streaming applications, or like with all data processing applications, you could schedule this, right? And you could use a scheduler like Airflow, or Google itself has its own, Google Cloud has its own scheduler technologies. That's fine. Or you could use Dataflow to be triggered based on the incoming event in a particular in a particular area. Like for instance, there's an incoming event and pops up, and then based on that event, the Dataflow gets triggered. Or the cloud function, Google Cloud function, which is a serverless simple execution. That Google Cloud function can itself trigger a Dataflow. So it could be any of number of different options. In terms of the entire aspect of security, like with all serverless technologies in the cloud, you could have this, you could have the service be access controlled. You could have this be operating in its own like virtual environment and things like that. We're not going to talk too much about security because it's outside the purview of this course, and pricing, etc. So all of this is something that you can actually look it up and read up more about it later on. What are the fundamental concepts here? Like I said, the programming model that is used by Dataflow is actually the Apache Beam open source implementation. So Beam itself has a bunch of different common concepts that need to be understood. First and foremost, the simplest application that can run on Beam is called a pipeline. Like the name suggests, it's a collection of different processing steps that happen one after another. And the pipelines themselves operate on what's called as a P collection or a parallel collection. So each step in the pipeline produces, or rather takes as input a P collection and produces a P collection as output. Whether the P collection is checkpointed, whether it's actually stored in memory or in disk, etc., all of that is optimizations that the execution environment of where the Beam is executed, or the Beam pipelines are executed, that decides it. Like in the case of Dataflow, for instance, it has its own optimization methods for this. The standard way in which you deal with the P collection is using transforms. This is very similar to the transform that you see that we saw in Spark as well. Transforms themselves are organized by basically having parallel executions of that in the most general sense, executing on multiple different workers at the same time. That's called a parallel do or PAR-do, right? That's the terminology that's used here. Obviously, you have access to input-output for being able to deal with external systems like storage systems, file systems, PubSub, and things like that. You can use your own functions to define custom functions that you can extend, or you use the standard aggregations which are already available within Beam, both in terms of combining multiple outputs within a machine and then shuffling. So optimizations around shuffling are also available within Dataflow, which Beam can exploit appropriately. But the most interesting part, in my view, is the ability for you to take a Beam job and run it on multiple different types of runners. So, like I said earlier, Beam is open source and provides a more general purpose language to specify data processing tasks, both batch as well as in real time, which means you could use appropriate runners and take that logic that you define using Beam and run it on an environment that supports your favorite execution model. So the programming model is separate from the execution model. And if you like, for instance, Spark's execution model, then you could take the Spark runner, and the Spark runner automatically converts the Beam job right into appropriate Spark specific concepts, right? And then runs it within a Spark environment. Like you could run Spark, let's say on Google Dataproc, right? Google Dataproc is basically the Hadoop on Google equivalent. right? Or you could run Spark on Databricks, which is completely different types of different execution environment, or you could just run Spark on your own virtual machine, right, that you manage. So in which case, you could take a Spark runner and take all of your Beam jobs and point it to the Spark runner, and the Spark runner will automatically convert a P collection into an RDD, transforms remain transforms, the actions for Spark become actions, the streaming operations that you do become structured streaming within Spark. So all of that, it gets mapped automatically, which is very, very powerful. Likewise, you could have a runner which converts the Beam job into a Flink execution environment, right? And benefits from the optimizations that Flink does. So it's quite fascinating to look at the Beam programming model and use something like this as the standardized way in which you represent all data processing tasks. Great. So with that, we have concluded this week's videos where we discussed about the streaming context and how is that fundamentally different from the batch processing context. And specifically, we talked about best practices around how we organize a streaming application, and the hot potato principle is like an important one there. And we saw an example technology of Google PubSub as one of the very good implementations of persistent store software, like the message service. And then we also took a look at Dataflow, which is again Google's serverless execution environment for streaming as well as batch processing, and how underneath it actually uses the Apache Beam SDK or Apache Beam programming model. And we also saw that programming model is actually more general purpose than most other applications, frameworks, streaming frameworks. And you could use the Beam programming model to instantiate your specific executions on different stream processing frameworks like Spark and Flink and such. In next week's video, we will take a look at the two open source options available for the message service as well as for the stream processing, which will be Kafka and Spark Streaming. Thank you.